Okay, so this is a video on how to take the CFP, which is in phase out now, over IO link to a PLC and get the level measurement of it. The variant I have does not have temperature. You can have a variant that has temperature as well. So once you've got your IO link master up, first thing to do is look at the IODD file. You see we get 4 bytes of data. Level is a 14-bit unsigned integer, and then temperature is a 12-bit, and it starts at byte 1, goes all the way through byte 2, and then some of it's byte 3. So since the IO link data is not a full word for each value, we'll have to distribute the bits to build words, unless you're using something like Function Block Factory. So I've already got a little bit of a PLC program written just to kind of show how this works out. So I'm coming in at D13000, but you can see that D13030 is where my IO link data is coming in for this sensor. So first thing that we have to do when we come to the PLC is we need to bring that data in. So I brought in 2 words or 4 bytes of data. You see I've kind of got it labeled here. I'm moving word 1 from P4, which is D13030, to a destination word of D654, and I'm doing the same thing with the second word. So those are the 4 bytes that are coming in that we saw on our IO link data here. So I move that data, and then I bring it down to a swap. So I did a byte swap for both of those words. So you see the 2, that just means 2 words that I'm swapping, starting at D654. So 654 and 655. I did a byte swap on both of those, and that gives me this data here. But since we're looking at just for level, is all I'm going to do this for, we're needing just 14 bits. I don't need the full 2 bytes. If I got full 2 bytes, and the temperature is going to bleed off into that, I'm not going to get the correct level. So to correct that, I'm going to do a transfer bits. So I've got a control word here, and you'll see here I've got a control word, a destination word, and a source word. So my control word will tell me how many bits is the first digit, the first bit in my destination, and then my first bit in my source. So looking at that, see if we can kind of look at both these at the same time. You can see that on D654, which is my first word that I did a byte swap with, I'm going to take 8 bits from that word, and I'm going to start at destination bit 0 is where it's going to go, and it's going to be coming from source. So from the source, the first 8 bits I'm going to put in the first bit, starting at the first bit of my destination word. And now, so I've got that, and I've built that byte of data into that word. So the next one, I need to get those other 6 bits out. So number of bits is 6. I'm going to start at 8 from my source, that you see here. And then I'm going to, from my destination, I'm going to start at 8. So I'm going to take 6 bits starting at bit 8 and dump into that word. So that built my 14-bit word, or took those 14 bits. And that gives me this value. So right now, if I put my hand all up, there's a 300 millimeter CFP. If I can get it to read all the way up to 300, then you'll see that it should, if I can get 300, there it is, it reached 12,000. So to get 300 out of it, like it's reading here, I divided by 4, and now you can see I've got 3,000, which is giving me down to 0.1 millimeter worth of resolution. So again, if I move my hand up and down it, and I go way back to 300, So that's how you would get that data out of it. If I wanted to do the temperature as well, then I would do the exact same thing. And these, I would just have to move that data and build a word. Since it's a 12-bit integer, then I would just have to take that data and move it. But this one is an integer where this is an unsigned integer. So be aware of that. If you're using Rockwell PLCs, I've seen people use this instruction here. It's a BTD instruction, and it does the exact same thing. And this sample right here is just doing they're doing a byte swap. So they're bringing the IO-Link data in, and the source bit, here's the destination bit, and the length. So again, starting at 0 for 8 bits, and then here, starting at 8 for 8 bits builds a 16-bit word. So to byte swap it, you would do this exact same thing, which would be the equivalent to what I have done here. And then to distribute the bits to build that word, you would be able to use the exact same instruction, but it would be laid out like mine is. It would be 0 and 8, same as here, and the next one would be 8 or 6 and 8. So instead of you having or starting at 8, 4, 6 bits, right, and then going into 8. So that's how you would build it. I know it's kind of confusing, but hopefully this helps.